Hi everyone, I'm Yingxin Wang, senior software engineer from Windows Essential Experience team. I have uh, been driving this project for several years. Also drive several projects within the Windows team. So this talk is about Proxy, and the title is Next Generation Polymorphism, which is also the title of our GitHub repository. So before we get started, I would like to show a little bit Appetizer. So if you look directly into this code, this is the code you can write with the next version of Proxy, not the current version. The support pro skill syntax is for the next major release. So let's keep go a little bit inside the code. So basically, we include proxy header file because proxy is a header-only library. You just include it. You don't need to link anything. Then you define a struct formattable. It's actually called a facade. Basically, define it with a facade builder. Specify it supports a format skill, and then build it. Then you have a type. This type is an empty type. It's a meta type. With a meta type, you can instantiate a pro-proxy object and assign anything to it, like P1, P2, and P3 are all proxy objects with the same type. But underlying, they have different types. Like the P1, the type is constitute string, pointer of constitute string. For P2, the underlying type is unique pointer. For P3, the underlying type is the return value of make proxy. Actually, the small buffer optimization automatically happens behind the scenes because the number, the double is small enough to fit in the buffer. So basically, we define three variables, and we can use them as the same type proxy. For P1, we can simply print line and put it in the function, same as P2, same as P3, and the output is exactly the same as the original type. You cannot do it with the C++ syntax today or in other languages. Like in Java, you have to override the toString function in the object base class, so as C#. But C++, you don't have this option. The only thing you can do is to define a virtual function on some type and invoke the virtual function. It cannot integrate precisely with a complicated library like std format library, but you can do it with proxy with just a single line support pro skills format. So for the rest of the talk, I will dive deep into what the three lines actually do. Okay, this is the overview of the talk. First, we will talk about the motivation, basic introduction of the library, some benchmarking numbers, the basic concepts, what is proxy, how to create it, and what prototypes you get, how to build a facade, and the last topic is skills. So we will basically cover every aspect in this overview of this talk. So first about motivation. The motivation is actually, I don't have multiple slides for this because, not because the motivation is trivial, but there are a lot of research about the motivation, especially the second bullet point. Virtual function in C++ has certain limitations. There are three talks. I highly encourage you to watch it if you haven't. So the first motivation is that we do want runtime polymorphism. It's a useful paradigm. Although we have stood variants in C++ 17 and a lot of template facilities, also reflection, but without runtime polymorphism, certain things cannot be implemented. So it's a useful paradigm. And the third one is the existing polymorphic wrappers in C++ are not sufficient. I specifically mean std function. And there are other polymorphic wrappers like std move only function in C++23 and std any in C++27. But the most widely deployed type should be std function. You might find std function is very useful in a lot of cases, but apparently not sufficient enough, at least compared to other facilities in other languages. So ultimately, we want to write polymorphic code as easily as in Java, C#, Go, or Rust, or any other languages. We want to make C++ better while keeping the C++ quality. So this is our ultimate goal. And as far as I know, Proxy is the only library that has implemented this feature. So a little bit about the background. It's open sourced. You can just navigate to github.com/Microsoft/proxy and to get the whole access to the library. The title is Next Generation Runtime Polymorphism in C++. It's licensed under the MIT license. You can use it freely for business or non-business. It's portable. It's header only. Before the 4.0 version, it's a single header library. But in the 4.0 version, it's not a single header library. It has another header that can interact with the FMT library if you have used it. Just similar to the Appetizer I just showed you, you can integrate it smoothly with the FMT library with just a very tiny header. And it's non-intrusive. Why non-intrusive is good? There are a lot of talks about this. I don't want to go deep into this topic. And this one is the most loved feature. It's well managed. What means well managed? It offers GC-like behavior. It actually offers different lifetime management model for each object, while the performance is not affected. But the behavior is similar to there's a GC behind the scenes. And the next one is fast. That's absolutely the key feature of C++, and we don't want to break it. In our benchmarking, you will see it's even faster than the built-in virtual functions. Accessible. It's a simple word, but it requires a lot of effort to implement it. The accessible includes diagnostics and API design, and ease of use, ease of learning. And it's also flexible. Any paradigm like inheritance, combination, and RTTI, all the paradigms can flexibly combine together. You can refer to the proxies frequently asked questions or proxy specifications. This specifications is for 3.0, 3.3.0. And the version I will demonstrate in this talk is not yet released, but we plan to release before the Build conference this year. A little bit background about this library. Is deployed in Windows since 2022. It's now available in both VCPKG and Conan. We initially published it in August 2022. You can see my blog post. We also have an announcement for the Proxy 3, the 3.0 version. I'm also a member of the ISO C++ committee. I also have 3 papers for this library. If you are interested, you can just download them and read them. It's initially open source in 2022, and the latest stable version is 3.3.0, and you can acquire this version both from Conan or VCPKG. And the next major version is Proxy 4. If you are using Proxy 3, you may experience ABI breaking change because we have improved the code generation. it offers better API and better diagnostics. But within a single major version, the API is considered stable. So let's talk a little bit about benchmarking. So we advertise it as fast. So how fast is it? We have automated our benchmarking in November last year. We test over 5 major environments, include different compilers like MSVC, GCC, Clang, Apple Clang, NVIDIA high performance computing, and on different platforms like Microsoft Windows Server, Ubuntu latest version, Mac OS on Apple Silicon, and we compare 20 metrics. You can just navigate to our pipeline and can acquire the report for each run, download it, and you can see the number. So this is the number I got from the latest recent build. From the indirect invocation, you can see MSVC is much faster than virtual functions. For small objects, it's even 300% faster. And for on Apple Clang on macOS, on the ARM-based chip, the advantage is not that significant, but we still see a difference between proxy and traditional inheritance-based polymorphism. We also tested NVIDIA high-performance computing. Number is a little bit different from other platforms. Different compiler will translate proxy into different machine code, but they're very similar. This is a part of the P0 lifetime management metrics we have today. You can see there are some red points, which is proxy is somewhat slower than like on Apple Clang on macOS. It's a little bit slower for compared to StudAny for lifetime management. We found the libc++ has some optimization in that, so we simply didn't do the optimization, but we can do it better if not optimized for general use. And other metrics look pretty good, especially on Windows. So the concepts. This ASCII diagram is the concept tree of the proxy library. It's based on facade. Facade is the overall abstraction of runtime abstraction. So it's an abstraction defined for abstraction. Within facade, we have convention types, which is the member functions, like stud format integration, and like proxy cast RTTI. And reflection allows you to embed any metadata to proxy library, and it will become super useful after C++ 26, because at that time we have a very powerful reflection infrastructure, like Imbo just introduced. And the third one is constraints. A set of constraints for pointer types. It includes maximum size, maximum alignment, copyability, relocatability, and destructibility. Each of the capability is a value of constraint level. There are 4 constraint levels in C++. The most relaxed is none, and non-trivial, then no through, and trivial. If you are familiar with type traits, you will see the type traits always named with the 4 constraint levels. And in this library, we abstract it as a enum constraint level. So if you browse the library, you will see there are several concepts. The first concept, facade, is just a diagram I just presented. So it specifies that a type models a facade. There are three other concepts. Proxiable means a pointer type can meets the requirements from the facade. Proxiable target specifies a value can be instantiated with a proxy view, which is the strict term of the proxiable target. You can simply take it as a type that has implemented all the indirect conventions. So in-place proxiable target is a stricter requirement than proxiable target. It specifies whether a value type can be instantiated within the footprint of a proxy object without allocation. It's useful, especially in embedded scenarios. So, proxy. This is a very rough overview of the proxy class. It's incomplete just for exposition. So a proxy inherits a bunch of accessors, and it offers indirection and dereference for all the four reference types. The memory layout is basically a vtable, similar to a virtual function. But the vtable could be embedded inside the proxy object if it's small enough, like it only has one function or one reflection or two functions. In this case, the vtable can directly embed into the proxy object and theoretically improve the invocation performance. And we did measure that in our benchmarking. So the second field is a byte array. It's aligned with the constraints maximum alignment, and the size is the maximum size. So you can basically put any pointer that's smaller than the size and the alignment is smaller or equal to the maximum alignment into this buffer, and it can hold it. It can mimic the exact behavior of the pointer. So these are the four key types of the proxy library. So proxy is the base type. It just, as I shown before, it wraps a pointer object matching the specific facade. It has two variants. The first is proxy view. Proxy view is an alias of proxy. The definition is actually proxy of observer facade. And for another important type is weak proxy, similar to weak pointer. If you are not using inheritance, so basically we do not encourage you to use C++11 smart pointers like unique pointer or shared pointer wrapped with a polymorphic object, and we just recommend you replace them with proxy. So let's see the basic definition of proxy. You can see the online documentation. These are the member functions. I won't go deep into that. Here's some comparison. For each documentation, we have examples. Like in this case, we define a member dispatch. You can basically take it as a member function definition. And we add a convention. The convention is the input type is int, output type is string. It actually forms a member function at. And the name is mem_at. You can basically create a library. Here I have a very tiny library. it takes a directory. I don't know the actual type of the directory. All I need to call is to just call pointer at, because it supports this operation. I don't need to know the underlying type. This function is not a template. It's a concrete type like std function. And from the client code, you can see we have two containers. One is a static map. Another one is a shared pointer of vector. We can put all the two types into this, implicitly convert to the proxy object and use it as if using the original type. And we just mentioned proxy view. Proxy view is just an alias of proxy. And you can define a proxy view of some fmap. You add a convention, the bracket operator. The input type is a key type. The return type is the reference of the value type. And you can invoke it as if invoking the original object. But the difference between proxy and proxy view is that proxy view never takes the ownership of the original object, similar to a row pointer. And this is, like I said before, similar to a std weak pointer. You can define a shared pointer and convert to a weak pointer, and you assign to the weak pointer to the weak proxy and lock it. Then you can just use it as if using a weak pointer. Okay. And that's all about the proxy itself. So how to create a proxy? We offer several creation functions. Also, you can create from a row pointer or any smart pointer, but we recommend you use the creation functions if possible, because they usually offer better performance, especially like make proxy shared is similar to make shared. Make proxy view is similar to just assigning a pointer to a proxy, but it honors reference. We can see a little bit about these types. Make proxy, similar to make unique, but it actually can allocate the proxy within the footprint of the proxy object if the object is small enough. And make proxy share similar to make shared. But if you are sensitive about space, you can observe on major platform implementation, shared pointer is usually the size of 2 pointer size. So that if you have a facade and you want to restrict the layout to just 1 pointer size, still shared pointer won't work. But make shared proxy will still work. Allocate proxy is similar to allocate shared, but similarly, it offers better performance. Make proxy view just like the borrow semantics in Rust. So let's come back. We will cover a little bit about the other parts, like dispatch prototypes. There are 7 dispatch prototypes in the library. Conversion dispatch is split into explicit conversion dispatch, also alias to conversion dispatch, and implicit conversion dispatch. Operator dispatch, you just saw, we can define an operator of brackets or other operator, even include comma. We also support that. Weak dispatch is something you want to have a default implementation, and if it's not implemented, it will just throw not implemented, but it will not generate a hard compile error. There are 3 macros here. The reason we use macro is because C++ does not support generating a member function with an arbitrary name, as we just saw, like the add function. We cannot simply provide a string literal add and ask the compiler to generate a function named add. We don't have this capability in C++26, but hopefully we can have it C++29. So at that time, we can get rid of those macros. Facade builder is all the magic happens within this type, because you can see the definition of facade is very complicated. Without a builder, it's very hard to write a correct facade, and the builder will help you to write and combine all the abstraction you have defined before. Let's take a quick look at the documentation. Here's the operator dispatch, and we define many operators, all the operators supported in C++. And these are the macros. We define the dispatch types. You can also give it an alias. It supports two syntax. You can give it a function name, and it just generates a function with the original function name. And you can also rename it to another name. And free functions, it will just go through ADL, like we have an example here. Like you can convert a toString into the toString free dispatch, and you can invoke it with toString without any qualifier, because it can find the function through ADL. And this is the facade builder. It has many documentation, but we will update it for the next major version. Here's a very tiny example. You can simply implement a std function and std move only function in just these simple lines. And you can simply invoke it as if it was invoking the original objects. Similar to std function, but you need a star here. That's the only difference. So skills, this is the last thing I want to highlight. This is the new feature in the next major release. We haven't announced it before, and we're announcing it in this conference. We have 5 set of skills. You can convert a proxy into a proxy view with sview, and you can convert to a weak proxy with sweak. You can make it support RTTI, like RTTI instead any with RTTI, direct RTTI, indirect RTTI. With specifying this, you will get 2 functions. One is proxy cast. You can cast anything, cast to the original type, like std any cast. And you have proxy type ID, like the standard type ID. And the format, W format, you just saw that before. And in this new version, we also have FMT format. You can integrate smoothly with the FMT library if you prefer to use that library. So the last thing I want to do is a quick demo about how you can use the support pro skills syntax in the code. I just use Visual Studio. You can use any IDE you like and any compiler. But this is not the code you can run with the latest stable version. It will be available for the next major version. So this is just the Appetizer code I just showed at the beginning of this meeting. I can just simply run it, and it will build. Drag the window here. See, the output is exactly what is expected. Yeah, that's all about my presentation. Thank you.